now let's talk about uncertainty. See, we are all living in the world in which is full of uncertain events. Okay, so how do we take care of those uncertain events? Okay, now I am facing uncertainty that how much insurance I have to buy, what is going to be, say for example, in case if I face an accident tomorrow, so should I take up an accident insurance? Okay, I might have to get hospitalized. I have to take that kind of insurance. Okay, so, and all of us at one level or the other, we are facing such decisions in our life. Okay, we are facing the decisions which involve a lot of uncertainty. Even you are facing such uncertain situations. For example, students, they face some uncertain situations. I, as a teacher, face some uncertain situations, and so on. Okay, so all of us are living in an uncertain world. How do we model that? Okay, so we have to take care of that expected utility theory. What does this say? Okay, what does this actually say? Well, it says nothing as such. Well, it says a lot. Well, say for example, I flip a coin. Okay, so I flip a coin, and of course it will turn either head or it will turn tail. Okay, well, in case if I flip a coin and if I get head, then say I'll win $100. If I lose, okay, that means in case if tail comes up, I lose, and well, I might lose how much? $200. This is the kind of the bet. Okay, or supposedly if I win, I win $400. Okay, because the point which I want to make will be clear to this. Okay, now these are my prizes. Okay, these are my prizes. Of course, the probability, this is your winning probability. Okay, winning probability is also half, losing probability is also half. Okay, now, well, we know this, that what is going to be my expected value. Okay, so what we calculate here is the expected value. In case if I enter into this gamble, what is the expected value of my wealth? So the probability of winning into the value of winning plus probability of losing into the value of losing. So the probability of winning is half, and the value of winning is 400. Probability of losing is half, and the value of losing is minus 200. Okay, so that would make 200 minus 100, which is $100. So on an average, in case if you repeat this experiment large number of times, you'll be getting this as the expected value. Okay, now, well, in case if you consider this, your expected value of this gamble is greater than 0. For the gambles which have the expected value equal to 0, they are called fair gambles or fair bets. This is definitely better than a fair bet. As you guys could see, you're getting an expected value which is greater than 0. Okay, would you want to take this bet? Okay, the question is, would you take this bet? Would you take this bet? See, sitting on a chair, okay, and when you don't have anything to lose or win, you might say, yes, I'll take this bet. But on an average, in case if you ask majority and you ask real money to be poured in and you ask them, okay, will you take this bet? Will you take this bet? Then on majority, you will find this, that people would not want even to take this fair bet. They do not want to take this fair bet because they think that they might lose this $200. They might lose this $200. So whatever gains they are making, the utility which they derive from making gains is lesser than the utility which they lose while losing. Okay, so the point is, individuals, they're not considering expected value. What are they considering? They're considering expected utility. They're considering utility. Okay, so what is more important is expected utility. They are concerned about the utility, not the expected value. Okay, so generally people are risk averse individuals. Okay, and how do they calculate? How do you calculate expected utility? So you calculate expected utility as the probability of winning, okay, into the utility of winning plus probability of losing into utility of losing. Okay, so in general, your utility functions, they have diminishing marginal utility. So utility functions exhibit diminishing marginal utility. So, well, you understand this thing, that is, and because of this diminishing marginal utility, the happiness which you derive from winning this bet would be lesser than the pain which you will have from losing this bet. Okay, so how do you calculate expected utility? I'll just let you know in a moment, but this is the way. Okay, so I'm giving you a fair bet, a bet in which your expected value is greater than 0, but still you do not want this. Okay, but still you may not want this. Well, you want this or do not want this, it depends on the kind of utility function which you have. Supposedly, if we have this kind of a utility function, say for example, I have the utility function u is equal to root of w. Okay, you will see this in many books. So u is equal to root of w, and your initial wealth is say how much we have taken out there. Okay, 200. Your initial wealth is 200. Okay, so your utility would be u is equal to root of 200. Okay, so well, this would be something would be equal to 14. Okay, approximately 14, I guess. Now the point is, what is your expected utility in this case? Expected utility is probability of winning into the utility which you get on winning plus probability of losing into the utility which you get from losing is equal to, what is the probability of winning in this case? 1 by 2, as you've seen. What is the utility of winning in this case? Utility of winning would be root of, you have $200. Okay. And in case if you win, then you'll be getting 200 plus $400. Okay. That is 200 plus $400. So that is $600 plus the probability of losing would be 1 by 2 into the utility of losing would be 0, because you have $200. If you lose, you'll lose $200, will be 0. So 1 by 2 into root of 600 would be somewhat around approximately 24. Okay. So that is 12. Approximately 12. Can you guys see something? This is the utility which you are getting without gamble. This is the utility which you are getting with gamble. You are better off without gamble. Okay. You're clearly better off without gamble. But this is all because of the kind of the utility function which you have assumed. We'll be talking about different other utility functions also. But this is one of the characteristic of the risk averse individual. Okay. He is better off without gamble. Fine. His utility is better off without gamble. And in case if he is presented with two gambles, one with a larger bet and other with a lower bet, and if he has to choose something out of these two gambles, he will choose a gamble with a lower risk. With a lower bet. You get the point? So this is an introduction to uncertainty problems.